Okay friends, welcome to part 2 of our video presentation on chapter 2 from your textbook. In the first part of this video presentation, we spent a lot of time talking about the so-called basic computing architecture. So we talked about the main components and we talked about the main technologies or devices being currently used in each of those areas, and also what kind of devices or technologies were used in the past, and also about managerial implications of some of those devices and technologies. Now, in the second part of this video presentation, we will talk about specific types of computers or specific types of computing systems that are out there. So we'll talk about such specific categories of computers as microcomputers that cost somewhere between a few $100 to a few $1,000. We'll talk about available mid-range systems. We'll talk about mainframes, which are powerful centralized computers used by large business and scientific organization. And we'll also talk about supercomputers, which are largely used, in scientific research and by very computation-intensive organizations. Now let's start with microcomputers. Now, for the general public, when somebody says computer, what they really envision, the way they really understand this term is that they imagine a microcomputer, the so-called personal computer or PC. Those are the kind of computers that are generally, carried, moved, or owned by one single person at home or at work. And specific examples include like a desktop PC, laptop or notebook. Also handheld or personal digital assistants such as PDAs or something similar to a tablet PC or iPad. Nowadays there is a new trend that is not mentioned here. There is that merge between a laptop with a touch screen and a desktop computer. It's called all-in-one computer, where you have like that standalone monitor that also has typical components of a desktop computer, like a DVD drive, speakers, and all the computing, all the architecture is hidden inside that monitor-like device. So it's being sold nowadays very often. Netbook is not mentioned here. It was hot, maybe 5-10 years ago. Not anymore. I think nobody's buying. Very few people are buying those little inexpensive laptop computers. So yeah, the first time is a microcomputer. So this is how it looks like. This is a typical layout of a laptop computer. This looks similar to the so-called tablet PCs. Now it's interesting that tablet PCs were popularized by HP Compaq. I owned one of those, and this computer, when in this kind of folded state, it looked like an iPad because it has a touch screen, and you could input information using a stylus. And then, like, if you turn it around, or if you turn the screen around, and you can also erect it like this, so this part becomes your keyboard. So it's interesting that HP pioneered this kind of device, but those kind of devices really took off, in my opinion, with the release of the so-called iPad, iPad computer by Apple. Now, when it comes to microcomputers, there are two major platforms or architecture: the so-called IBM Compatible Computer and Apple Microcomputer. I think IBM has roughly 80% market share, and Apple has the remaining 20 or 10% market share. And Apple microcomputers, they are based on their own operating system, Mac OS. For a number of years, they had their own unique hardware components. All the things are changing, and I think even Apple computers nowadays are using CPUs from Intel. Now, it's interesting to reflect on the history here, on how those two competing platforms came into existence. Again, as I told you before, if you really want to find out more about the history of microcomputers, watch this movie, Pirates of the Silicon Valley. So, in this movie, they talk about basically, first of all, from the Microsoft side, they talk about Paul Allen, one of the school friends of Bill Gates. So Paul Allen and Bill Gates, they became excited about the so-called Altari computer, and that was like one of those first relatively inexpensive and simple desktop computers. So by looking at this microcomputer, they realized how much potential computing has when it comes to the households, and also individual usage in business in the office. And it was around the time when Steve Jobs and the other Steve of Apple, his name was Steve Wozniak. He's also one of the main characters in the movie. That was the time when they were active members of the so-called homebrew computer club somewhere in Northern California in the Silicon Valley area. And it was largely, I mean, both of them, they were excited about building those microcomputers, but it was largely Steve Jobs who saw the potential, saw the potential of, creating and selling microcomputers and the kind of profound impact they will have on business and society. Now, according to Steve Wozniak, or the other Steve, or Woz as he is called in Apple, he never had this idea of starting a company. I mean, he was working with those microcomputers because he liked electronics, but the thought of assembling computers for sale never occurred to him. But Steve Jobs persuaded him to do that, and that's how Apple started. But one interesting observation here is that at that time, big players such as IBM, they saw very little potential in microcomputing industry. So they kind of missed on that opportunity. And this is where guys from Microsoft and Apple came in, because they did see the potential in microcomputers. And they started building those hardware architectures, and eventually, and actually it was also the time when IBM did not see much potential in software business per se, because IBM viewed themselves as a company that is in hardware business. So both Microsoft and Apple, they saw that potential in microcomputer hardware, in microcomputer architecture. They also saw potential in software. And that's how those two giant companies started. This is something that gives you a powerful lesson that, if you want to compete with giants such as IBM, don't compete with them in their own, playing field. Try to compete with them in a different landscape where they're not present and not particularly strong. Eventually, IBM realized the potential of microcomputers, and they started popularizing their IBM compatible, the so-called IBM Compatible Architecture. Yeah, they started popularizing their IBM Compatible Architecture, and they kind of beat Apple architecture because they had this large market share. One of the ways they beat Apple architecture or platform is that they made it they made their platform more or less open to other hardware vendors. So basically, all kinds of hardware companies, they started producing components such as hard drives and video cards specifically for the IBM platform, IBM architecture. And I remember, like in the old days, it was like common for people to specify, like when they're selling a computer or marketing a computer, they would say it's an IBM PC, meaning like IBM PC compatible computer. And there are all kinds of vendors here. Now, Apple kept their architecture for a long time proprietary because they wanted to have like a full control of all the components, how they work together, of the operating system. Now, that it wasn't like a nonsensical idea. It did pay off because Apple computers, they're notorious for being very user-friendly, user-reliable, and in part, this kind of outcome was achieved by Apple having complete control over their proprietary hardware architecture and operating system. Now, a lot of times people like to kind of portray Apple as being the loser of the of the desktop race. I don't think it's quite true, because although they don't have a dominant market share like IBM compatible PCs, you have to understand that they do have a sizable market share of around between 10 or 20%, and the kind of margins they're getting on their products, are very high, because a typical price for an Apple computer, like an iMac or something like that, the typical price is a few $1,000s, and I'm pretty sure they're making a huge profit margin on the sales of those devices. So by no means they're losers of that race. They are quite successful, just that the strategy that they're using is a bit different. In a strategy field, that would be called like a niche or differentiation strategy. So they're not trying to create a computer for that broad mass market. They're trying to create computers for that niche of people who appreciate elegance and stability and user friendliness, because a lot of Apple devices that and software applications that kind of plug and play. You don't have to mess with drivers like you do with IBM compatible PCs. So this is something that attracts a certain group of people, and that group of people is willing to pay quite a bit of money for that. So by no means Apple is the loser of that personal computer race. As you know, personal computers or microcomputers or desktop computers, they have been used for all kinds of purposes, for record keeping, for word processing, for creating presentations, also for programming. And they also used to implement the so-called client-server architecture, that the one that I discussed in the first part of this presentation. Now, mid-range systems in 1980s and up to 1990s, they were called workstations and mini-computers. So physically, workstations and mini-computers, they looked similar to a desktop, but they had like more powerful architecture, more powerful processing unit, more larger hard drive. And they were typically used by scientists or engineers for such applications as computer-aided design, simulation, like stress test in architecture and so forth. Nowadays, mid-range systems, also include servers for running, a particular web server, let's say Apache web server. There are also like high-end variations of those mid-range systems, that are used for, more powerful organizational servers or web servers. Mainframe computers are another type of specific computer system. They're basically very powerful computer platforms. They're used by large organizations or by scientific companies for network control, for online and batch processing of corporate data. They're also used as web servers. Major players in mainframe industry include IBM, Fujitsu, Unisys. Now things may have changed since the time this slide was put together, because all those companies, they keep entering, exiting business. Like Hitachi, Hitachi was a major player. I think they exited the mainframe business, a while ago. IBM, has been, I would say, the leader, or had been the leader, up until the current decade or the 1990s. Fujitsu, together with Hitachi, they were like kind of trying to catch up with IBM, and what they would do, they would try to always to kind of borrow or recreate whatever IBM comes up with, in terms of the architecture, and they would make some improvements and try to charge a lower price for that. But those guys, they still remain some of the top players in the mainframe computer industry. And then there's another category of specific computer systems called supercomputers. Now, those computers, they have the processing capacity of thousands, sometimes millions MFLOPS. They handle largely problems generated by or problems formulated by scientists. Something related to weather, to genome, to encryption, decryption. Typically, they are located in universities, government labs, research, R&D, research and development labs and facilities. The cost for those computers can range from a few $1 million to hundreds of millions of dollars. Again, there have been many supercomputers built. Things are changing so fast. Every few months or so, you get some kind of news message about a new supercomputer being built that seems to outperform the predecessor. One computer worth mentioning is Ibm Blue, and again, I think there have been many variations of Ibm Blue. There'll be like, I think there was like a Ibm Deep Blue. Now there is Ibm Watson, I think, which is like a new version of Ibm Blue. But Ibm Blue is famous for one particular thing. Ibm Blue and the computer itself and the software was the first computer to beat a well-known chess master in the game of chess. So more specifically, Ibm Blue was able to beat Garry Kasparov, one of the most well-decorated chess masters currently alive, in a multi-game match of chess. Now, Garry Kasparov, he's still disputing the results of this match, because according to Garry Kasparov, it wasn't the computer who beat him, it was still a computer working together with humans who beat him. And I think apparently, his argument has some grounds, because when Ibm Blue was playing against Garry Kasparov, there was a team of IBM engineers kind of supervising how this computer worked. They were just doing some kind of adjustments, I think, to the algorithm or to the architecture or something like that, or that's what Garry Kasparov alleges, that there was a group of engineers, adjusting computer during the match. So he's saying that, he wasn't beat by computers, he was beat by a powerful computer together with humans. But that again, this Ibm Blue architecture, it kind of gets you thinking about this book and the ideas expressed in this book, The Second Machine Age, because this kind of milestone is over. In other words, computers already they already beat a chess master in the game of chess. Now, of course, the game of chess is not as unstructured as some of the real world scenarios that we're getting, But nevertheless, things seem to be moving into this direction. Chess today, tomorrow it will be like computers beating humans in Jeopardy. And by the way, that's exactly what IBM is trying to do right now with their Watson computer. They want to make sure that this computer beats the Jeopardy champion in this particular game. And when that happens, that will be another milestone. And then the next milestone will be, I don't know, computers beating humans in composing songs or writing novels or something like that. Now, one thing about supercomputers, I posted a link here about Titan supercomputer. That seems to be like an offshoot of or a new version of the Jaguar computer created in Oak Ridge National Laboratory somewhere here in Tennessee, not far from here. So take a look. You'll see how those computers assemble, how they look like. But that kind of grid approach is becoming common, where a supercomputer is built by linking together like a small, less powerful computer in one huge grid, and all those grid components, they work together in parallel. So watch that video there posted to Canvas about Titan supercomputer that is somewhere here, not far from here in Tennessee. Okay, friends, so this concludes the second part of our video presentation on Chapter 2. So we are done with discussing various hardware platforms. So thank you for listening.